be your presenter today. And with that, let's get right to it. So today's session is on getting started with AWS and migrating data to AWS. Here on this slide, you will see what we'll be covering today. So first, we will be starting from the basics. Let's create a new AWS account. Then we have to remember that security is the number one thing you have to think about first. So let's create an IAM user and enable multi-factor authentication. IAM stands for Identity and Access Management. Once we have a user, we can then launch a virtual machine or EC2 instance, Amazon Elastic Compute Cloud, and we can SSH or secure shell connect to the new instance. Once this is up, we can create some volumes, we can snapshot those, and make a backup copy of our new instance. After that, we can look at Amazon S3 simple storage service, create a bucket, store some files there, and serve those back to us. We'll be taking a look at AWS cost and billing consoles. And then finally, like Chris mentioned in the beginning, we can start looking at data services on AWS, how to ingest data into those services, and what are the different options you have for backing up, restoring, archiving data on AWS. Now let's start from the beginning. What exactly is cloud computing? Well, think of cloud computing as a utility. What else is a utility these days? Well, electricity, water, and gas. The characteristics of such utilities are that basically it's on-demand delivered. Whenever you need more electricity, you just plug in a device to a standardized interface, and you start consuming the utility. You are metered for your usage. It's the same with the cloud. You have virtually unlimited capacity. And in case of cloud computing, you don't need to build the IT infrastructure yourself. We deliver the IT infrastructure and platform services to you over the internet, and everything is fully pay-as-you-go pricing. There is no upfront fee, there's no minimum payment, there's no long-term commitment. And when you get started, new accounts on AWS enjoy our free tier. Most of the AWS services have a free tier. It means that when you create a new account, which we will be doing together next, for 1 year typically you can enjoy the free tier, which gives you a nice opportunity of testing and trying the AWS services without any costs incurred. The best way to learn about cloud computing and to start using the cloud is simply to start using it and trying it for yourself. Everything we saw today can be done within the free tier. And here you can see the URL. It's always aws.amazon.com/free in this case to explore our free tier. And if you want to get started and create a new AWS account, all you need to do is navigate to aws.amazon.com, and you will see there a big button that says create a new account. You will need a credit card, but note that when you have a new account, when you stay within the free tier that is documented on our site, you will not be charged for anything. There is a telephone verification step when you sign up a new account, so please keep that in mind. Now with that, let's jump right into the first demo, which is signing up for AWS. Let's create a new AWS account together. First, let's switch to a browser. Now, here we have the AWS Amazon Web Services Web Console. There's many ways of using our cloud. Typically, people start by using the AWS console. The other options are developer access with our SDKs and APIs, and then the command line tool. But first, let's start from the basics. Before we get to the console at all, how do we actually create a new AWS account? So here I've logged in with another browser to aws.amazon.com, and you can see on the top right-hand corner of the screen a button that says Create an AWS account. So let me click that one, and let's see what happens. Now I won't be running through all of the steps here because that would incur the telephone verification steps, etc. We don't have time for that in this webinar, but let's walk you through most of the steps here. So for example, let's create an email address, webinaruser@amazon.com. It doesn't actually exist, but we need to enter an email address here. You would be entering your actual email address or mobile number here. Then you select that I am indeed a new user and click Next. Let's put our name here, webinar user. We have to type in the email address again, and then a new password. And then we click on create a new account. This literally just takes a few minutes. And after that, you will have a new account and you will start enjoying the new AWS free tier. Now in this next screen, you can then select whether you have a corporate account or a personal account. In this case, I will select personal account. I am in Singapore. Let me just fill in some details here so we get to the next screen. And some phone number which is not existing. We will not get to that step. There's a security check to see whether I'm a bot or not, so I am a real human. I should be able to detect the letters there. We check that we have read and agreed to the terms. You can click on the link to read the AWS customer agreement, and then we simply click on create account and continue. Now in this step, you would be then entering your credit card number, and note again that when you stay within the free tier, you do not incur any credit card charges there. You can also set up a billing alert. I can show you later where those are. That gives you an alarm if any bills would be coming your way. Now this is where we will be stopping this particular demo because we would need to input an actual credit card number here, and the next step is the phone verification. Anyway, you get an idea here that with just a few simple steps here, a few screens of information, you will easily and handily create a new AWS account, and you can start using it immediately. And I urge you to start exploring the free tier and trying the AWS services for yourself. That's always the best way to start using the cloud. Now with that, let's get back to the slides and continue. Once you have created a new account, the first step should be to create some users. Now the best practice here is that you have something called a root account. Your root account is the one where you do your billing, your identity and access management settings, your security settings, etc. But the best practice is not to use your root account for your everyday cloud activities. For your everyday activities, when you really use the cloud, the best practice is to create another user, a so-called IAM user, and then for this user you can assign access policies. What is the user allowed to do? What is the user not allowed to do? And if you have a corporate environment, you can have different policies, different groups, different users who have limited access only to those resources that they need to access and nothing else. So using the service called AWS Identity and Access Management, we make it easy for customers to create such users or groups of users and then attach policies that you can define for these users. So then the next step is a reminder. Multi-factor authentication. We cannot stress this enough. Please, please, please activate and start using multi-factor authentication. With MFA, it means that you will have a username and a password to log into AWS console, but additionally, you will need to have a PIN code that the MFA device provides. So you have a two-factor authentication to secure your account. The device can be either a physical device from Gemalto that you can order online or a virtual device, which in reality means that you're running an app, a mobile app on your iOS or Android phone, a free app, and then this app is your virtual token device. We highly recommend you to enable this on your IAM admin users and especially the root account for AWS. Now let's see how that actually works. Let's, in the next demo, create a new IAM user, see how that's done, and enable multi-factor authentication for our new user. So let's get back to the console. So here we are. In this browser window, you can see that we have logged into the AWS console, our web console. We can see that my account is Markku, that's my name, and I'm using an IAM user that is also called Markku. That is slightly confusing. Anyway, here I am logged in as my admin user. You can see here on the console that we have the 70 or so AWS services listed here. So basically the first page here is just a jump page from where you can start administering the different AWS services. Briefly, we have grouped our services available to you under different categories such as compute, storage, developer tools, security services, databases, etc. Now for this particular demo, we will be looking at identity and access management. It's under security services, so let me click on IAM. And when I click on that, this takes us to the IAM console. This is the place where you do your security settings for your account and your users. You can assign users to groups such as developers, administrators, operations staff, tech support, etc. Then you can have individual users defined here, and the users and groups can be assigned security roles and policies that define in a whitelisting mode what are these users and groups of users allowed to do. Whitelisting means that only those things defined can be done and everything else is denied. So always remember in the cloud that the best security practice is to whitelist everything. Blacklisting means that you are trying to block the bad things, but it's mathematically impossible to know all the bad things. So you have to turn it around. Start using whitelisting security. It's called least privilege principle. So basically you only allow the smallest possible things that enable your users to do their work, the work that they need to do, and everything else is denied. So for example, developers should not necessarily access the production systems, operations staff should not access the testing systems, etc. Anyway, for this particular demo, what we want to do is to create a new IAM user and then enable multi-factor authentication for this user. So let's start by clicking on the Users tab here. You can see that I have some users in my account. Now we will click on Create New Users. Now we could create multiple users here, but in this case I will just enable one new user called Demo2. We have an option here to generate an access key. If you use developer-based access for your user, you want to use the command line tool or maybe APIs to program from your application against the AWS cloud, then you need an access key. With this access key, you authenticate your application or your user against this particular user in IAM. So yes, I want to have an access key. Now we click on Create. Now AWS IAM service has created a new user called Demo2, and it has also created a new access key and a secret access key for this particular user. If you want to use those, this is the opportunity for you to capture this information. The system will only show you these once. So either you screenshot this one, or on the bottom right-hand corner of the screen you can see a button to download the credentials. So I click on that, and my laptop downloads these new credentials as a file on my laptop file system. So you keep a copy of these. Anyway, you can always recreate them again from scratch if necessary. Now as you can see, we have a new user called Demo2. Demo2 user is not assigned to any groups because it's a new user, so let's fix that by adding this new user to a group. By default, my account has two groups, administrators and power users. You can create more groups with predefined security settings, any settings that you wish to have for your groups. In this case, I will select the power users group, and I click on Add this new user to this power user group. What does that mean? It means that now this new user called Demo2 has inherited the security settings for my power user access group. On the bottom here, we can see that the user is part of the power users group, and we can also show the security policy. In this particular case, the power users are allowed to use all the AWS services in my account except identity and access management itself. There we go. In the Security Credentials tab, we can see the access key, We can create a new access key if necessary. And we can, for example, do some password management for this particular new user. There is no password yet. There's no login password for this new user. So let's fix that. Let's click on Manage the password. We could assign a custom password, or we can let the system auto-generate a nicely secure new password string. And we can require this new user to create a new password the first time they actually sign in. So let's do that. I click on Apply. And just like with the access keys earlier, now the platform has generated a key, in this case a password. We can see it here on the screen, and it will show it to us only once. So again, it's a good idea to click this Download Credentials button. And as you can see, my laptop downloaded a file which contains this particular user's information, including this one-time password for the first login. This is the information you would then pass on to this real user, that here you go, here's your new account, this is where you log in, that's your username, and this is your password. And the first time they log in with this password, the system will prompt them to create a new password that only they will keep for themselves. And finally, we want to then enable MFA, or multi-factor authentication. You can see that currently MFA is not enabled for this user, so we'll click on this button, Manage MFA Device. Here we have a choice whether we want to use a virtual MFA device, which in practice means a phone, a mobile phone with an app, or a hardware device. It's easier and cheaper to use a virtual MFA device, so I will use that. So let's click Next. This is just a reminder prompt here that you have to install an app on the phone, and I can actually click on the link and we can see what are the options for multi-factor authentication. So here on this web page we can see that if you want to use a virtual MFA device, you can use on Android the Google Authenticator app, or Authy. On iPhone you can use Google Authenticator, and on Windows Phone the Authenticator app. And on BlackBerry again the Google Authenticator. Now these are free apps that you can download from the App Store for your particular phone ecosystem. The other options are to purchase a hardware key from Gemalto. And then interestingly there's also an SMS option. So with SMS you can have text messages sent to your phone and you can reply to those. So again, use your mobile device, but you can have a feature phone and still you can do multi-factor authentication if you're not able to install apps on your iOS, etc. device. Anyway, those were the MFA device options. Let's just click Next. We have chosen to use a virtual device. And now the platform gives us a QR code here. So what we are supposed to do now is to go to a mobile phone, use the Authenticator app, and we can scan this QR code and then basically add this new MFA user or information to the app. And let's do that in real life. I've actually connected one of my old iPhones to my laptop. You can see the screen mirrored here. And on my phone screen you can see that I have installed the Google Authenticator, in this case on the iPhone. So let me click on the Authenticator app. You can see that I have one MFA device already configured on my phone, which is my account's root account. On the Authenticator app there's a plus button there to add a new user. So let me click on plus, and let me click on scan barcode next. And now you can see my laptop there. Basically all I needed to do was to point my phone at the screen. The app detected the QR code on the screen and it automatically added here on the Google Authenticator app my account. You can see that this particular code that's changing next is for the Demo 2 user, the new user we just created at Markku, which is my account in AWS. Now, all I need to do then next time is, if I log in as the Demo 2 user to the AWS console, is that the console will prompt me for my password. I will enter that, and then it will prompt me for this particular code. I need to use this app on my phone, enter the ever-changing code, and that's the second level of authentication then. There we go. Well, we would need to enter the codes and then activate the device. Anyway, you get the point, that's how it works. Let's get back to the slides. Next, what have we done so far? We've created a new account, or I've shown you the first steps how to do that. We've created a new user, assigned it to the Power Users group, and activated multi-factor authentication. After that, it means that you can actually start using your AWS account. And typically, what people start with is to start using services like Amazon EC2, Elastic Compute Cloud, to spin up virtual machines. And then to connect to those virtual machines and to start managing them, you need SSH keys. SSH stands for Secure Shell, which is a secure login over the internet to your servers. That is actually our next demo then. Let's now create an SSH key using the EC2 console in AWS, and later on we will see then how to use these keys. So let's jump back to the next demo. Let's create a new SSH key using the EC2 console. So here we are back in the AWS console. We are still in IAM. We go back to the main page of the console and we find EC2. It's under Compute, EC2 or Virtual Servers in the Cloud. I click on that and this takes us to the EC2 console. Now here we can see that we have one instance running, we have some volumes, key pairs, etc. In this particular demo step, we want to create a new key pair. So under Network and Security options here, we have key pairs. Let me click on that. And then simply all we need to do if you don't have any keys or you need a new one is to click on Create a new key pair. Let's give it a name like Webinar Key and click Create. And maybe you noticed that something happened. My laptop or my browser automatically downloaded this new private key to my laptop. So you have the private key, you need to store it securely on your devices, on your client devices like your laptops, and then you use this private key to log into your servers in the cloud. AWS does not have your private key, only you have it. There you go. If necessary, you can of course delete these keys, and you can also import key pairs if you have created your keys somewhere else and you want to continue using your existing SSH keys. But this is how easy it is to create a new SSH key anytime you need one. All right. Next, security groups. So we have an SSH key, which means that we will be eventually able to then log in securely to our Linux systems in the cloud with EC2 virtual servers. And once we are running virtual servers in the cloud, we want to secure them. So basically we want to use something like firewalls. In Amazon EC2, we have the concept of security groups. Security groups are firewall rules that can help you secure your instances. By default, the system blocks all the traffic. So you need to enable port by port, one by one, the incoming or outgoing traffic that you need. So by default, all incoming traffic is blocked. You can create security groups and you can attach those to your running instances or servers. And the security groups then define what access, network access, you can have between you, your administrator, public internet towards your instances, if necessary, or between instances. You can use, for example, groups of IP addresses, individual IP addresses, etc., to determine the source addresses that are allowed to access different ports on your servers. Or you can have multiple EC2 instances or multiple servers sharing a security group, allowing them to communicate with each other. Let's see how this works. Let's go back to the EC2 console and create a new security group that, for example, allows SSH login from my laptop and maybe HTTP or web access to a web server running on the server. So let's jump back to the console. We are back here in the EC2 console, and what we want to do next is to create a firewall rule or security group. So it's here under Network and Security. Let me click on security groups. You can see that I have quite a few in my system. Let's create a new security group. So let me click on create new security group. We give it a name, webinar example security group, SSH and HTTPS access. Something we haven't talked about yet is virtual private cloud. So in brief, we have two types of networking for Amazon EC2 in our platform. There's classic EC2 networking and there's virtual private cloud. With VPC or virtual private cloud, you have much greater control of your network settings. You can create your own subnets, your routing rules, etc. You don't necessarily need to have any internet access. So when you create a security group, you will create the security groups either in classic EC2 networking or in virtual private cloud. In this particular case, I will create it in classic EC2. But the experience is exactly the same. With VPC, you have even more control over the networking. So what we want to do is to add some rules to our firewall rules. So I click on Add Rule, and the first rule could be SSH. So we select SSH from this drop-down list, Secure Shell. You can see that SSH is by default TCP port 22. So that's the port that the service is operating on. So you will need to run SSH daemon or SSH service on the server you're connecting to. By default, most Linux distributions do this, including the Amazon Linux distribution. And then you can select who is allowed to connect with SSH or from where are you allowed to connect. It could be from anywhere, or even more secure, we can have the platform detect my current public IP. So my current source IP from AWS's point of view is here. One particular IP address /32, which means this IP address only. So this rule specifies that I can use SSH to connect to a server when we attach this to the server, but I can only access from this particular source IP. Just to give an example, we can then add some more rules, like eventually we would be running maybe a web server on this server, so we can add HTTP port 80 and HTTPS port 443 from anywhere to this server. Or this rule, and later we will be then attaching this rule if we want to a running server. I'm just showing you that we can filter and find the particular rule that we just created. I'm searching for webinar because the name of the rule contains webinar here. We can see the inbound rules here, and we can at any point edit these rules if necessary. So now we have created a security group. Let's get back to our system. And in the next step, let's launch an EC2 instance. So with Amazon EC2, you can run servers in the cloud. You can choose from various instance sizes with different CPU, memory, disk configuration, etc. And you pay for them by the hour. You can deploy one, you can deploy 1,000. When you don't need them, you shut them down again and you stop paying for them. So in the next quick demo, let's create and launch a new server with Amazon EC2 and connect to that. So in the console, we are still in the EC2 console. I click on instances. You can see that I'm running one already. I made this yesterday, called Linux pre-created one. And let's now click on launch instance and create a new EC2 instance from scratch. Here we have a selection of some popular operating systems as a starting point. You can also have your own operating system images. We have a marketplace with thousands of pre-created software appliances, and we have community-provided server images. In this quick demo, I will just choose the Amazon Linux AMI or Amazon Machine image. So basically, we choose an image of the operating system that we want our servers to be running. Here in this next page, I can choose how large the virtual machine is that we want to be running. And you can see that the default selection is a T2 micro, so a small server with one virtual CPU, and it's eligible for the free tier. So that's nice. Let's choose this T2 micro instance type. Next, we can choose how many servers we want to deploy. So it's as easy to deploy 10 servers as it is to deploy just one. We can choose where to deploy it, EC2 Classic, default virtual private cloud, etc. There's a lot of configurations and settings you can do here, but let's not get into all those details now. Let's just click Next. We keep the defaults. In this next page, we can change the size of our disk attached to the virtual machine. We can add more disk volumes if we want. We can choose a different type of disk, from magnetic to SSD, for example. We can give a name or tag to this instance. I will just type here Linux. It's always a good idea to use tags so you can identify later what is this resource that I created in the cloud, and you can find it easier later. Next, we will select the security group. So why don't we find the security group that we created earlier? No, I created in the EC2 Classic. Never mind. This is now VPC. That's why we can't see it. So let's create a new security group. And in this particular case, we only allow SSH. And again, let's do the same trick as earlier. We allow SSH only from my current source IP. So the reason I couldn't find the webinar security group is that we created that in EC2 Classic, but this EC2 instance is being now created in VPC. So you have different security groups in VPC and EC2 Classic. Anyway, we create a new one that allows SSH only. And next, we just want to review our settings and click on Launch. When you launch the instance, the system is prompting you to select an SSH key. You will use this particular SSH key then later to SSH or log into the instance. So I should have the demo key on my laptop. You need to keep the private key. And now we go back to the EC2 console. And we can see that we have now two instances. One of them I created yesterday, and one of them is now being created for us. So basically what happened is that the console made an API call to the AWS EC2 platform and requested a new virtual machine of size T2 micro from the Amazon Linux distribution, created in my default VPC, and now it's booting up. When you select the particular instance, like we have done here, we can see some details of the instance here. We can see, for example, the private IP address with the internal networking in the VPC, a virtual private cloud. We can see that it has one network interface, one root device or volume attached to it. That's the boot volume. You can add more if you want. And here, in this particular case, we can see that this instance has a public IP address. It doesn't necessarily have to have. So you can have subnets in VPC where you have private IP addresses only. For example, your databases would not necessarily have any public IP addresses. They would be private facing only. Okay, now it's been booting up for a while. The storage type for this instance is SSD, so it boots pretty quickly. So how would we connect to this instance? I select the instance here and I click on the Connect button. If this was a Windows instance, we would be able to download an RDP file, remote desktop protocol file, double-click that and then connect to it. Because this is a Linux-based instance, we use SSH. So the platform is giving us here an example string, SSH command string. I can copy that to my clipboard and go to my terminal and paste the example command to my terminal window here. And let's see if this works. You can see it's SSH with my key, logging in as the EC2 user, which is the default user for Amazon Linux, to the address of this newly created instance. I press enter. Are you sure you want to connect to this host? Yes. So now we are logged in. And this particular server has existed for 2 minutes. And just to show you, you have full administration privileges here. So we can, for example, do sudo yum update and sudo yum. Okay, that's all. That's all we need actually. Okay. Good. We are logged in. What do we want to do next? Let's get back to the slides. Next, we can talk about storage volumes. So with the EC2 instances, you have root volumes, but you can also add additional disk volumes with EBS, Elastic Block Store. Your EBS volumes that you create, you manage them separately from the instances. You can create them, you can mount them to the instances, you can detach them again and keep them, you can shut down your servers, and you can keep your data on these EBS volumes. They can be from 1 gigabyte to currently 16 terabytes in size. And you can snapshot or back up these storage volumes from the servers to Amazon S3. We have different types of disks that you can use, from SSD drives to provisioned IOPS, very fast SSD drives where you set the performance needed. And we have different types of magnetic storage, for example, throughput optimized HDDs with very high consistent read and write speeds, and then cold HDDs, which are very cost efficient for the type of data that you don't need to scan very often. And the new default type for your EC2 instances is the general purpose SSD drive, giving you very nice random I/O performance. For example, the instances boot very quickly using the SSD drives. Let's see those. Let's have a quick demo where we create an EBS volume and we attach that to our new instance. And we can then also snapshot this volume to Amazon S3. So we are back in the console. We click on the EBS console here. We click on Create New Volume. We can choose the type of the disk. Let's keep it as general purpose SSD. We can specify the size, how many gigabytes, and then which availability zone to create it to. Our instance is running on availability zone Southeast 1B. So let's create this volume in the same, or disk in the same availability zone, so we can mount it on our newly created instance. I click on Create, and we refresh the screen, and you can see that indeed we now have a new volume, 100 gigabytes volume that is available. So it's not attached to any particular instance. It's not attached to any server. It's just hanging there. So we select this new volume. We go to Actions, and we select Attach. Now basically what we want to do is to attach this new volume to our server that we just created earlier. So I select the new server. We can see that it should be called SDF on Linux side. That's the device name. I click on Attach. So what happened now is that the system or platform attached this drive to this new server that we are running. Let's refresh the screen, and we can see here that this volume has now been attached to our server. Is that so? Let's get back to the server, and let's scan our block devices. You can see that we have two devices now. The root volume is already mounted, and root is mounted on this volume, and we have a new disk device VDF that's 100 gigabytes in size. That's the new EBS volume we just created and attached to this particular Linux instance. So now you can create a file system there, you can mount it on your operating system, and you can start using this volume. And then handily you can detach the volume, keep your data, and shut down your instance. Okay, next in the demo what we want to do is to snapshot the volume. Okay, we have the volume selected here in the EBS console. We can go to Actions, and we can select Create a Snapshot. My first snapshot, initial data dump. So basically what a snapshot means is that the platform will take a snapshot of the state of the data on this particular volume, and it makes a backup copy of the data to Amazon S3, which is a separate service with 11 nines of durability. And then you can at any point restore your storage volumes from this point of time backups from Amazon S3. And then finally, this demo includes creating an AMI, or Amazon Machine Linux image. We have a server. We could modify the server. Once you are happy with your server, you've installed your configurations and your applications there, you can select the server in the EC2 console and go to Image and select Create Image. my first server image right after creation. You would make new AMIs, new server images, every time you modify your system. Typically people use now automation methods to do this automatically, but that's another story. Basically what you do here is that you snapshot not just the storage volumes, but your entire server, your boot volume. And then subsequent servers you can then create from these images. So if you install some applications there, you can then have 5 or 10 or 20 servers that are all identical, booted up from your custom server image. You can choose the volumes you want to include in this image. In this case, I only choose the root volume, and then you click on Create Image. And now what happens is that actually the server will shut down so that the file system is consistent. The platform takes a snapshot image of the root file system, and then the server boots back up. After this happens, you will have a new Amazon machine image, and then you can create EC2 instances from these images. Moving on. I mentioned Amazon S3 earlier. So with Amazon S3, you can have unlimited storage capacity for storing files in the AWS cloud. S3 has 11 nines of durability, and you can encrypt the data as you go with your keys if you want. Let's have a quick demo of Amazon S3, which is the basis for storing files in the Amazon cloud. So we go back to the console. We find S3 under the storage services. We go to the S3 console, and when we get the console, we can see my existing buckets. So with Amazon S3, you have a concept of buckets, and then within the buckets, you have objects or files. Let's create a new bucket. Let's call it a webinar 1, 2, 3, 4. You can choose the region where you create your bucket, and your data stays in that particular region. So when I select Singapore region for my bucket, and I store any files there, oops, this has already been taken. Let's make our bucket name even more random and longer. There we go. So now we have a new bucket, webinar, whatever. And this particular bucket is now empty. When we want to start using Amazon S3, we create a bucket as we did just now, and then we can upload files to Amazon S3. We can add files with the console. We can use the command line tool. We can use our SDKs, or we can simply drag and drop files. So I have a nice image here on my desktop. Let me just drop this here in this console window, p1.jpg, and I click Start Upload. There. Now we uploaded a file to this Amazon S3 bucket. And when we select the file and look at the properties of this, we can see that there is a link to this file. So S3 is not only a storage service, it's also able to deliver the content to your users and customers over the internet. However, by default, the objects are private. So when I click on the link, we will see an access denied message. By default, we don't have access to download this object from the internet side. So let's quickly change that. We add some permissions that everyone is able to open and download this particular object. So now when I click on the link, you can see the link is S3 Southeast 1, which means Singapore, the webinar bucket, and file p1.jpg. When I click on this link, S3 delivers us this content now over the internet. So that's a nice McLaren P1 hypercar there. And then to save costs, once you're done with the object, you can simply delete it. And just to remind you how to be cost efficient, let's do the same in EC2. Let's select the new Linux instance we created earlier and terminate that one. So always shut down and remove all the resources in the cloud that you're not actually actively using to optimize your costs and spending. That was a quick demo on Amazon S3. Now, billing and cost management. I talked about cost optimization. We have several features in the AWS console to help you visualize and monitor your spending. We have the Cost Explorer. You can make billing alerts, you can look at detailed billing reports, and also for corporate customers you can have consolidated billing where you have a master account and then you can assign different accounts for your different departments or different projects and products, and you can pay your bill centrally and you can monitor the spending of your different organizational departments. Now with that, let's move on to the next part, and with only a few minutes remaining in this webinar, I will briefly highlight the different options for storage in the AWS cloud and how to transfer data to AWS. Basically, the AWS platform is a large platform with different storage services. You have file services, we have block services, you saw EBS, Elastic Block Store earlier. We have Amazon S3 and Glacier, our archiving service, for storing objects. And then we have database services, etc. So there's various types of data storage services in the cloud, and then you have various ways of transferring data to those services or from those services. The most simple way is over the internet, either with normal internet or with the VPN tunnel. Basically, it just means that you use your existing internet connection and upload data to Amazon S3, for example, like we did earlier with the photo of the McLaren P1. We did normal internet uploading, but the other option is that you have VPC or virtual private cloud where you specify all the networks, and then you can create VPN tunnels by yourself to AWS to your VPC. And when you upload data to S3 using the internet or VPN, it's recommended to use some multipath upload mode. In basically multipath upload, you have multiple TCP streams uploading the data in chunks. This is accelerating and improving your upload experience significantly faster, and if any of the chunks have any transmission issues during in the network, those chunks can then be retransmitted without having to retransmit the whole large file in a single stream. To make data upload to Amazon S3 faster, we have a service called Transfer Acceleration. So when you enable this service, you don't need to upload your data directly to your S3 bucket. Your S3 region might be far geographically. So with Amazon S3 Transfer Acceleration, you can use our Edge network to download to a nearby Amazon location and then use the Amazon network internally cross-region. How does this work? Let's say that you are in India and you want to upload to Amazon region US East, which is very far geographically. Instead of uploading directly from your laptop to Amazon S3 in US East, when you use the Transfer Acceleration service, AWS will find the nearest edge location, which could be in the same country or nearby country from you. You upload to a nearby AWS location, and then the rest of the way, the files are transferred using Amazon internal WAN networks, which are optimized for this transfer. It's significantly better for you, and typically you enjoy up to 50%, even 400% increase in the network performance for uploads. It's extremely simple to use Transfer Acceleration. All you need to do is enable this feature for your S3 bucket. And then instead of uploading straight to your S3 bucket, you just use S3 Accelerate for your bucket to upload using these edge locations. How much does it help? These are some tests that we have done. The blue graph here, or the blue bar, shows native direct upload from a remote location to Singapore. So from South America to Singapore, it takes quite a long time because it's geographically far. But when you enable the Transfer Acceleration, you can see that you get significant speed up. You get consistently higher performance and lower latency. Another way of uploading files using the Amazon networking is to use our CloudFront CDN service. Amazon CloudFront is our content delivery network with currently 55 edge locations worldwide. It's not just used to transfer objects and files to your customers. You can also use CloudFront to ingest data into the cloud. So simply, all you need to do is you create a CloudFront distribution using the console of Amazon CloudFront, and then you can enable uploading. So you can start uploading from your customers' machines to the Amazon Edge locations, and then CloudFront can receive and ingest your data and you can receive your data in our load balancing service with a farm of servers behind, or Amazon EC2 servers, S3 buckets, or any custom origin, even in your office, maybe using a VPN link. So just like with S3 transfer acceleration, here we use the CloudFront edge locations to have a short, low latency, high throughput connection from your customers to a nearby Amazon location, and then we use the Amazon internal networking the rest of the way. Now I mentioned your corporate offices earlier. So in case of enterprises, our enterprises can enjoy using our AWS Direct Connect service. So with Direct Connect, you can provision your own dedicated private cables and links to AWS. You can have 1 gig or even 10 gig Ethernet links straight to AWS, and you will connect these to your virtual private cloud. Here we have one option where you have your corporate office or data center, and you can connect your networks to a common co-location facility such as Equinix. We list these co-location facilities on our website. And basically you just cross-connect from your router to the AWS backbone network. If you don't have presence in a co-location facility with us, you may have an ISV partner who do. So in this case then the AWS partner will cross-connect to the AWS network, and the ISV partner will then provide you with their link connecting to your corporate office or data center. So in both of these cases, still you are bypassing the internet and you have a fully private end-to-end connection securely to AWS. So with Amazon VPC and these private connections, AWS becomes a secure extension of your existing data centers and systems. With real-time data ingestion, we have the Kinesis family of services. So very briefly, just highlighting that Amazon Kinesis is a family of services where you can stream real-time data from your mobile devices, from your web servers, from your IoT devices, packet by packet, payload by payload. You can act on the data, or using, for example, the Kinesis Firehose service, you can very easily ingest any amount of data into Amazon S3 or Redshift. You don't need to do any coding to use Amazon Kinesis Firehose. You simply start posting data to Firehose. Firehose will automatically handle things like scalability, batching data, encrypting the data if you want, and then storing it in the destination service like Amazon S3 buckets or Amazon Redshift data warehouse. It's a really simple way of starting to ingest any amounts of real-time streaming data. With AWS Storage Gateway, you have another option of running a virtual appliance in your network. You can have storage volumes that are locally stored in your data center. So you can run the AWS Storage Gateway appliance on a virtual machine in VMware ESX or Hyper-V on your server, and then the Storage Gateway will snapshot and copy and back up your data to AWS, basically to Amazon S3, EBS Snapshots, or Glacier, which is our archiving service. How does Storage Gateway connect to AWS? With the methods that we discussed earlier: Internet, S3 transfer acceleration, or Direct Connect private pipes. You can have gateway stored volumes, where the data is actually stored on the gateway in your system, and then it makes point-in-time snapshots to AWS. You can have gateway cached volumes, where all the data is stored in AWS, and the most frequently accessed data is stored locally on the gateway appliance. And finally, you can replace your tape drives with a virtual tape library, giving you an iSCSI device that looks like a tape, but you get rid of the hassle of managing tapes. Finally, to complement the offerings of storage and data ingestion, we have a large partner ecosystem. Here you have some of the examples, and the partner offerings are then complementing the AWS services, so please do take a look at those as well. Thank you very much. I really hope that you enjoyed this short presentation.